Hello everyone, and this is our presentation about advanced database project called MyHealth. We decided to create a database for hospitals which could contain all information about patients, doctors, treatment, procedures, medicine, and other information which may be necessary to have for a hospital. Since hospitals have a lot of problems with data about patients and transferring it, this database could be used to transfer any important information faster and cheaper. If the information flow between hospitals is better, then patients won't have to wait a lot of time for getting help. This can result in more patients getting help in a shorter amount of time, which is very important thing for a hospital. We have chosen this topic because we think it can improve very important part of life for every person. It can help people to save money and time spent on health-related issues. As I said before, it makes all medical processes faster, like registering, going to a different hospital, and sending data about patients between hospitals. Our solution is an application called MyHealth, which allows people to register and make appointments with doctors. This application saves information about everything what is important for patient's health, so the patient can check his health history in the application, for example. These are more detailed data which we want to have in our database. These are information about hospitals, like where they are located, as well as information about appointments, treatments, medicines and procedures, and of course information about patients and doctors. So any person using this application can check their history of appointments or procedures. They can check what medicine they used to take, or which hospital they visited, or who was the doctor they had appointment with.
Requirement specifications. The requirement specification that we have got can be divided into two types, which are functional and non-functional. For the functional requirement specifications, a patient can make an appointment with the doctor. They can choose the date, time, doctor, hospital in order to make an appointment. They can also see their history and show the valid medicine, treatment, and procedure that they have been taken as their history to the doctors. For the non-functional requirement specifications, all of data has its full backup every day and still lasts long for a month. All sensitive data have stored as a ciphertext. Use RDS from Amazon Web Service to handle necessary tasks. Conceptual model. In the conceptual model, 9 tables are included: person, patient, doctor, schedule, hospital, medicine, appointment, order, and procedure. Person table is the table that contains information about person. They can be patient or doctor. Schedule is table that contains schedule of the doctor, which doctor available in what days. Schedule is connected to hospital because the hospital must manage schedule for doctors. Appointment table is the table that contains the appointment information. It's connected with the patient because patient might be able to make an appointment. The appointment also include information about medicine, procedure, and orders, so these T tables are connected to the appointment. Logical model. In the logical model, 22 tables are included. The main concept tables in the conceptual model are still remain the same, but some tables are added to describe more details. So let's start with the first main table. Person table. The person table is the table that stores information about person including both doctors and patients, which will be specified in another table called person type. And to remove many-to-many relationship between person and person type, we also created another table called person hash type. Zip code and city tables are created to eliminate the transitive functional dependency in the address column in person. Specialist type and doctor hash type tables are also created to define the specialist type of a person who is a doctor. For the appointment table, schedules, medicine giving, procedures, order, and stay tables are connected to it. Schedules is the table that contains the doctor's schedules, which also connected to the hospital, same as in the conceptual model. For the procedures, we also created another table called procedure type to define the procedures types. For the order table, we realized that we will have more than one record in one order, so we decided to create another table called item to define each record in an order. Stay table is the table that contains the information about the patient that have to stay in the hospital. Medicine given is the table that contains the medicine that the doctors give to the patients. And to see more detail about the medicine, we have medicine table, which also have medicine type, medicine detail, medicine unit, and company to define more details about the medicines. Physical model. For the physical model, everything is the same as the logical model, but we added data type for each column. The IDs with each the primary key in the every table, we assign integer as the data type. For the string information, we assign varchar as the data type. And there's some column that will have date as the data type, which are birthed in person. And some columns have time as the data type, which are start time and end time in appointment table.
Hello everyone, I'm Bank, and this is my part is implementation. First of all, before we can start the project, at least we must select the right person to design the whole database. The reason that we should select the right person is for more scalable in the future and to maintain the project and a lot of things. After that, we need to select who is database administrator to give him or her for the database access and to take all of the responsibility of the database like monitoring or managing data and also security. And next one is select a DBMS. As we know that there is a lot of DBMS provide like Oracle, PostgreSQL, MySQL Server. But in this case, we should select it from the requirement. Everything also have its pros and cons. So we should select DBMS based on which cons that is acceptable according to our project. In this case, we can use a PostgreSQL because it also supports the AES. The AES is an algorithm to encrypt the data, like to encrypt the password. And it also supports the MVCC. It's to handle with a large amount of concurrent user. And here is the most important part. To complete the detail of requirement to make sure that we are doing it in the right way. Then the data structure is not that a big deal because if the database is well designed, every single column also define a data structure by its name, like street number, it should be a number only. our name, our first name, it should be a Varsha, and last name should be a Varsha. It shouldn't be a number or something else. Yeah. And yeah, we should have a approve, review and approve to make sure that everyone is okay with this design. And yeah, if the database admin, they sometimes they didn't have experience in this application, so we should have at least a schedule to training them, to let them understand the database structure, and also to the programmer too, to train them to understand to how to use a select or insert or update. It's a DML language, data manipulate language. Yeah. And everything should have evaluate to make sure that the user is okay with this design, or client is feel good after they use our database. It's not that slow, and it's also have a security. That's all. And according to our project, I guess our project is contain a lot of history data. It contain a procedure, medicine, a history of everything of every patient in Finland. So I guess it should be around. It should be more than a million record. So I guess 1 terabyte is enough, I guess. And the backup plan, we planning to have backup data and store it in the Amazon S3 bucket every day, and it can stay last long for a month. And we should give access right to the right person, right role. Like DBA can use the author or create the data. DB writer can use the insert, update, and delete. And also the DB reader or client, yeah, can just only select on the readable data. Yeah. And that's all for my part.
So, hi, my name is Luis Romero. And so now that my teammates have talked about the problem, the solution, the requirements, conceptual and logical model, it's time to talk about the problems we faced during the development of the project. The first problem that we encountered was when we uh, tried to model a schedule for a doctor because we thought of different possibilities that could happen. For example, if the doctor is not available or left for holidays, how will we manage? So we figured out that we were modeling in a wrong way. For example, if the doctor was not available, then we just won't show the time in which he's not available. Also, we thought of giving the patient the ability to see his appointment or her appointment scheduled on their side, so they won't have to remember when did they book an appointment. The second issue that we faced was when we tried to model the type of persons, because at the beginning we thought that the application will be just for patients, but then after asking the right requirements, we thought of adding doctor as a new role on the application. Having the doctor in the database will help us to let the user know with who they had the appointment, what time, and also manage the booking of the appointments. With the doctor in the picture, we had to add new data to the model. For example, if the doctor has any kind of specialties. Also, we can have the possibility of the doctor having more than one specialty. That's why we created the doctor has specialty table to remove many to many relationships. And also, I think it's worth mentioning, if the doctors don't have any specialties, then they will fit in the general doctor category inside the specialty table. Um, in terms of the medicines, one big issue we had was when we tried to model the medicine prescription, because in this paper you can have the medicines to buy, what presentation, and then the actual prescription of how much you have to take of each medicine. So we could have many medicines and many descriptions. And so then you can see the problem. The way we fixed this problem was by connecting the appointment table with the start and time fields inside this table with the medicine table that had the size in terms of grams field. We were going to connect these two tables with a new table in the middle. This table will store the amount of each medicine that was bought and a description of how much should the patient take. So these were I think the most challenging issues we had during the development process. But other than that, we managed to ask the professor for any doubts we had in terms of the Finnish health system, so he could give us a possible solutions. So this is the end of the presentation. I hope you like our idea of trying to combine all health data in Finland in just one big database. This will help not only doctors to reduce time in the diagnosis of patients, but also will help to save money for the users and the patients, and making the registering, the changing hospitals, and sending data a faster process. So this is our application. It's called MyHealth, and I hope you'll like it. And thank you very much.